So this question says that a rectangle in quadrant 1 has one corner on the graph of y equals 25 minus x squared and another at the origin. So that's what it looks like. And we want to describe the area of that function as a function of x. So let's think about that. We'll go ahead and we'll draw it. I'll exaggerate some of the shape a little bit. So this is y equals 25 minus x squared. And we are drawing a rectangle. We want to find the biggest such rectangle we can find. So this is a point xy. So of course this length is x and this length is y. So the area of the rectangle, which I guess I can color in green a little bit here. The area of the rectangle is just x times y. But we would like to have a function of x and x alone, so we're going to take the area is x times 25 minus x squared. So that's what I'm going to call y1 on my graphing calculator. Y1 is going to equal x times 25 minus x squared. So I think we have the first part answered. So construct a function of x to express the area. So fine, we can do that. We can say area as a function of x is x times 25 minus x squared. X times 25 minus x squared is our first pass on this. Next it says draw a graph of that function. So we're going to go ahead and do that on the graphing calculator again. So let's go there. So y equals x times 25 minus x squared. Well, I can do zoom decimal because x really can't be anything more than 5. So 0 to 5 is not bad, but I don't think I'm going to have near enough y. So I'll go ahead and I'll do zoom decimal to set the x value, but you can see the y is way off. So what do we want our window to be? How high do we want to go? Well, maybe I'll take a y max of 100. Let's see if that's good enough. And then we'll scale it at 10. Looks pretty good. So that's my maximum value. So we have a reasonable graph. If you want to see the stuff on the left, you can, but really I only care about the positive stuff. So maybe I'll even adjust this and make the x-min just -1, because I don't really need to see anything on the negative side. So there's a decent graph that I'm going to want to use. Now what's the next thing that it asks me to do? It says use a graphing calculator to find the maximum value of that function. Okay, so we'll go back to that and we'll use our max finder. Second calculate maximum is here. Move the cursor a little bit to the left of the top. Move it a little bit to the right of the top. And guess. And what do we have? We have the maximum that it gives me is x is 2.887. y1, which is not the same y1, remember y1, which is area. Area, which equals y1, is 48.113. So let's go back and look at the question again. We've done that. What is the x value that results in the rectangle with the maximum area? That was our x is 2.887. Now, what is the y value that results in the rectangle with maximum area? What do we say about that? Well, remember our equation was y equals 25 minus x squared. So if X is 2.887 here on my graph, Y should be what? Y should be 25 minus 2.887 squared. That's the actual Y value on the parabola. 25 minus 2.887 squared gives me 16.665. So we go back and look at our questions again. Y value that results in a rectangle with a maximum area. We found Y equals 16.665. Then it asks us what was the largest possible area of the rectangle. But remember, when we looked at this, we had this 48.113 thing, right? That was area. X times 25 minus X squared was the area. So the maximum area is about 48.11. But there's another way we can find that or check it. We say that was again about 48.11. But let's take a look at my picture. If X is 2.887 and Y is 16.665, you see the area here would be XY. Should be 2.887 times 16.665. And what does that give me? Hopefully something around 48.11. What do we get? 2.887 times 16.665, and we get 48.11. So that agrees.